Hey everyone, and welcome to The Explainer. I am genuinely super excited to dive into our topic today. It sounds a bit like pure science fiction, but it's actually the very real technology driving almost everything we interact with on a daily basis: machine learning. Today, we're going to completely demystify how machines actually acquire knowledge, which is literally changing the way we interact with the digital world. But hey, before we even start talking about machines, we kind of need to take a step back and ask ourselves a pretty deep, almost philosophical question. What exactly is learning? As humans, we learn by doing, right? By making mistakes, by observing, trying again. But how on earth do we translate that incredibly organic, messy, biological process into cold, hard code? Well, to answer that, let's look at this fantastic foundational quote from Herbert Simon way back in 1983. He defined it by saying, "Learning is any change in a system that allows it to perform better the second time on repetition of the same task." This very human concept, just simply getting better with practice, is exactly what we are now programming machines to do. Okay, let's dive into this because there's a really brilliant contrast here. With traditional programming, you feed a computer raw data and a strict set of rules. That's the program, and it computes an output. It only does exactly what you tell it to do, nothing more. But machine learning? It completely flips the script. You give the computer the data and the labels, essentially showing it the output you want, and the computer actually creates the program itself. It writes its own logic based on experience. How cool is that? So here's our roadmap for the explainer today. 1. Defining machine learning. 2. Supervised learning. 3. Unsupervised learning. 4. Reinforcement learning. And finally, 5. Summary of learning types. Let's get right into it. Section 1, Defining machine learning. We're going to look at the formal mechanics of what makes a machine a true learner. Tom Mitchell came up with this really elegant framework for a well-defined learning task. Basically, a machine is officially learning if it improves its performance, which we call P, at a very specific task, T, strictly through experience, E. So, for example, if an algorithm gets faster and more accurate at recognizing faces, the more faces it sees, it is learning through experience. Simple, right? Moving right along to Section 2, Supervised Learning, or Guided Training. You can think of this category kind of like having a teacher in the classroom who hands you a worksheet, but also gives you the exact answer key so you can check your work as you go. And this brilliantly illustrates exactly how supervised learning works in real life. We're looking at a standard email filtering system here. It takes incoming email lists, pushes them through a filter, and sorts them into good emails and bad emails, or spam. Let's break down this real-life example mechanically so we can really grasp the core concepts. First off, what's the input data? Well, it's the raw text, the sender info, and the subject lines of those incoming emails. Next, what is the system actually trying to learn? Its goal is to accurately classify those emails into two distinct buckets, good or spam. Now, what type of learning is this? It's supervised learning. And finally, why does it belong to that specific learning type? Simply because we explicitly trained it using pre-labeled data. A human teacher previously went in and tagged thousands of historical emails as either spam or safe, and the machine learned the patterns from those predefined answers. Now, what's really interesting about this is how we can take that exact same guided learning and apply it to something literally life-saving: human health. We can actually train a system to predict whether a medical tumor is benign or malignant based solely on its size. Let's apply our framework one more time to reinforce this. The input data here is a continuous physical measurement, tumor size. The system goal is to predict a specific category, malignant or benign. The learning type is, again, supervised, and it belongs to this type strictly because the historical training data it learned from came with predefined classes given by human doctors. The machine is essentially just mapping new, completely unseen data to the categories it was explicitly taught to recognize. All right, Section 3, Unsupervised Learning, or Finding Patterns. Imagine a scenario where there is no teacher, no answer key, and the class labels are completely unknown. The machine is essentially working blind to find hidden structures. Take a look at this cluster of totally unlabeled data dots, mapping weight against height. The system's goal here is definitely not classification. It's not trying to put things into predefined, neat little boxes like spam or malignant. Instead, its goal is clustering. It's trying to group similar instances together purely on its own. So, looking closely at these unlabeled dots, how many clusters do you get?
Seriously, I want you to mentally try grouping these dots right now, before the machine does the work for you. Do you see 2 natural groups? Maybe 3?
When an unsupervised algorithm tackles raw data like this, it reveals hidden structures based entirely on mathematical similarities. Depending on the data, it might formulate cluster 1 by an object's form, grouping square items away from round items, or cluster 2 by edibility, edible versus inedible, or maybe cluster 3 strictly by color. It is unsupervised because absolutely nobody gave it the labels square or edible. It just organically noticed those patterns all by itself.
Okay, Section 4, Reinforcement Learning, focusing on reward systems. This is the most general, dynamic, and frankly, the most interactive type of machine learning we have today. In this model, the machine is focused on learning a policy. A policy is really just a system's way of behaving, the actions it chooses to take, at any given time based on feedback from its environment. So the crucial point here is that there is no supervisor telling it the exact right move. Instead, it interacts with the environment, receives a delayed reward, and adapts its behavior to maximize that reward over time. Consider these incredible real-life applications, because they're pretty mind-blowing. When a machine learns to play chess, the input is its game moves, and the delayed reward is victory at the end of the game. It learns over time which moves lead to that final reward. In ping pong, the interaction is paddle hits, and the reward is a point scored. Even biological animals learn this way, right? The interaction is food intake, the positive reward is feeling full, and the negative reward is hunger. The system simply learns to chase the positive outcome. We have covered a massive amount of ground today. Section 5, Summary of Learning Types. Let's move to the next slide and see how this all builds together into a cohesive picture. I absolutely love this adorable Chibi-style robot illustration because it perfectly visualizes the core concepts we've explored today. Think about it. If this little robot is learning from a stack of books where all the correct answers are already highlighted in neon yellow by a teacher, well, that's supervised learning. If the robot is staring at a completely blank book and starts independently finding its own hidden patterns and groupings from scratch, that's unsupervised learning. And if this little robot learns to navigate a complex maze by getting a tiny battery charge every time it makes a correct right turn, that's reinforcement learning. As we wrap up this explainer, I want to leave you with a thought. Look at the challenges around you. Which type of machine learning, supervised, unsupervised, or reinforcement, would be best suited to solve the most complex problem in your own life? Thank you so much for focusing in with me today. Keep analyzing your world and keep learning.